Stellar Energy by Haley Frater. This graph has numbers that were gotten from right here, and this is the Earth and how far it is from point A to point B to point C, and so on, which is shown right here, and then it's just made into a graph, which is this right here, and it shows the different radiations. So that's how we got the information on that. HR 8799 emits more energy than the sun does. The energy peak for the sun is 0.5, and you can tell this by going to the highest point and going straight down. The energy peak for HR 8799 is 0.3, and again you can tell this by going straight down. It's 0.3. Yes, you can get sunburnt from HR 8799 because it has all the same things as the sun, and you can get sunburnt from the sun. Therefore, you could get sunburnt by HR 879. Both of these models help me learn in multiple ways. Some of the ways is because if there's no tilt, for example, this one right here, then the radiation that is received on one part of the Earth would be the same all the way down, which we figured out in one of our labs that we did. But if it is slanted, such as this one down here, there's a difference if this were shaded, but there's a difference in what the final percent of day that they get. So for this one, the final percent of day that they get for the lit up is they all receive 12 hours a day, but for here, some days, some parts could receive like 3 hours a day worth of sunlight, or some receive 12 hours, some receive 23 hours. It just depends on the math. And then this helped me because this shows where each part of the Earth gets its sun. So here, only this half of the Earth gets its sun. Here, the whole Earth gets its sun. Here, only this half, the opposite half, gets the sun, and here none of our half of the Earth receives sun. So that's how those help me. I believe that what the statement said, which the statement was today, was such sure a cold day. As the Earth orbited the sun, winter occurs when the Earth is farthest from the sun. But the Earth always stays in this orbit going around like this. Therefore, it doesn't get farther away from the sun. Technically, the Earth doesn't, but different sides of the Earth where it is spinning like this do get farther away from the sun. As you can see, these arrows show you how it spins around and around, but as far as technically getting further away from the sun, it doesn't get further away from the sun. It stays the same distance away from the sun, and the Earth itself just turns as it goes around in a circle around the sun. So only certain parts of the Earth don't receive sun, therefore making it winter or summer or different things like that.